solved problem number 14, and that was the last problem that we solved. So today we are going to continue with some of these problems over here. I don't know how many problems I'll be able to solve, but let's see, maybe one or two problems today, and then we'll call it a day. So let's look at, and these are problems that I haven't actually seen before, so yeah, this is going to be interesting. So let's look at these problems. So the first problem is lattice parts. A lot of people have been able to solve this. So there's power digit sum, then there is number letter counts, there's maximum path sum. Okay, whatever these things are. Let's start with the first one, lattice parts. So let's start a new notebook like that, and this will be problem 15. There you go. So this is problem 15. Problem 15, and this is called lattice parts. That's what it is. Okay. And the problem is starting on the top left corner. Blah blah blah. I think I can paste the link. Like that, and image, something like that. No. Okay. Insert and image in Markdown. Okay, how do I do that? How do I display? Okay, something like that. Okay. So the thing has to come outside like that. Will this work? Ah, perfect. Nice. Okay. And how many such roots are there in a 20 by 20 grid? Okay, so what are they talking about? Starting from the top left corner of a 2 by 2 grid, so that's a 2 by 2 grid. Okay. And only being able to move to the right and down. So we go right or down. Okay, there are exactly 6 roots to the bottom corner. So that's one, that's one, that's one, that's one, that's one, and that's one. Okay, this is calling out for a let's see, let me bring my iPad in over here. Let's see if we can find some pattern. I'm not sure how to do this. Okay, let's see. So we have a 2 by 2 grid, and okay, and we can go right. This looks like a, so any of this is like a Manhattan distance. So the total distance you cover is that 2 in the west. Is it the west or the east? 2 towards the east, and 2, so 2 towards the bottom. So it's that one and that one. 2 towards the south. So you need to go 2 units and 2 units to the right and 2 units down to reach this point. So if you have an n by n grid, so let's say you have a 3 by 3 grid like that, and you want it to go down, you still have to go 3 to the right and 3 to the bottom. So that's that one, and that one. Okay, so you can go to the right, you can go to the bottom 3 ways, this 3 ways. Oh, but then you have to go down also 3 ways. So you have a total of 6, 2, 3, 4, 5, 6 ways of going. 6, you have to take 6 steps, 3 of which are left, 3 of which are right. So let's say you go down 1 and right, so that's down and right, down and right. Okay, and then you go down and then right, then you just have to go down and right. So given this, you have to do this. Okay, how many ways can you go down? Let me see. Let's say you have 4, 5, 6 things you have to do, and you only have 3 ways of going down, 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 down. So you can choose to go down anywhere, down, down, down. That is, let's call this, that's 6 choose to, or combination. So this is 6 factorial by 6 choose 3, 3 factorial into 6 minus 3 factorial. That is equal to 6 factorial divided by 3 factorial by 3 factorial. Okay, now this is the number of ways in which you can go down. Number of ways you can go right is fixed. Right. That's the only way you can go to the right. You have no other choice. So this is it. This is the answer. So if you have a 3 by 3 grid, it's that number. If you have a 20 by 20 grid, you'd have 20 factorial with 40 factorial over here. And 40 minus 20 factorial. So that's 40 factorial by 20 factorial and 20 factorial. That is the number. I think I'm, oh, let's check if this is correct. So for the 2 by 2 grid, 2 by 2, I have 4 factorial by 2 factorial times 2. So this is 4 times 3 times 2, 2 times 2, 6. Is that the number? Aha! 6 roots. Okay, I think this may be a solution. I don't know. Let's see if this is a solution. So the answer is 20 factorial, and in Python you can just do factorial 40. This will be a really big number, but in Python it's okay. Imagine that, huh? In Python it's okay. This is ridiculous. Okay, let's try this. Math dot 20 squared. Okay, there are that many. That's a really large number of roots. Is it correct? Okay. Wow. Okay, we solved this quite fast. Okay, let's save this. Let's go to the next problem. This was quite easy. Okay, so we have solved this lattice parts. Next is power digit sum. This is another one of those things where we can do this ridiculous thing in, okay, problem 16. I think we can just do this. Problem 16, power digit sum. I think we can do this very easily, given that Python has this ridiculous two to the power 15 equals that. What is the sum of 2 to the power of that? I made a boo-boo. It's 15, and this should be okay. If 2 to the power 15, sum of the digits is that. So basically that is 2 to the power 15. In Python it's that. You convert it into this string, you map int, and then you take the sum 26. Okay, and then you convert it into 1000. What? Why is this such a small number? Something wrong? What? This is probably wrong. Oh, some of the digits, yeah. It should be, yeah, problem 16 solved. Yeah, pretty simple. Number letter counts. Okay, we solve this. Number letter counts. To counts maximum path sum 1. What is this? Counting Sundays. Wow. It's 18. Let's do 17 first. That's 17. Okay. If the numbers 1 to 5 are written out in words 1, 2, 3, 4, 5, and then there are 3 plus 3 plus 5 plus with letters. Okay, so this has 3 letters, this has 3 letters, this has THRE is 4 letters, 4 letters, 19 letters is in total. Okay, if you say so. So if all the numbers from 1 to 1000 inclusive were written out in words, how many letters would be used? This looks like a boring problem. Let me just save this and let me shut this down. This one will be problem 17. Okay. This is called number letter counts. Okay, and this is the problem. This is going to be a boring problem. Let's see. We have to go all the way up to 1000. So it's 1000 is 1000. Okay, so just need to write down 1 is 1, 2 is 2, 3 is 3, 4 is, this is why I said it was boring, 4, 5 is, yeah, 5, 6 is 6, we done. 7 is 7, 8 is 8, 9 is 9, 10 is 10, 13, 11 is 11, 12 is 12, 13 is 13, 14 is 14, 15 is 15, 16 is 16, 17 is 17, 18. I don't know if the spellings are correct. I am terrible at spellings. 18, 19 is Actually, is there a letter number words? Book a free class. Why am I writing these things? Let's use this position. Why can't I get a never mind, let me just write it. 18, I'm nearly done. 20. So it's 21, 22, so I don't need anything else. I need 30 is 30, and then 40 is 40, 50 is 50, like that. 60 is 60. This is getting really boring. 70 is 70. 80 is 80. 90 is 90. 100. So 115 is 115. So we'll just put 100 is 100. Okay. And 1000 is a 1000. It's just called, it's called 1000. Very good. And 1000 is called 1000. 1000. Okay. Like that. 1, 2, 3, 4, 5, 6, 7. I hope the spellings are correct. Otherwise, things are not going to work out. So, now given a number n, okay, if n equals 1000, Oh, return, so I should keep it numdict. Okay, I should return numdict, and like that. Okay, if n equals 100, wait, do not count spaces or hyphens. If n is greater than equal to 100, so hundreds is n percentage 100. No, n by 100, hundreds and rest, tens equals n percentage 100. So whatever is left. Okay. Do I look? Oh, n now if it's already there, don't calculate it. It should be 100. Actually, I don't even need this. Yeah. If n in numdict, okay, just return numdict and just that. Okay. If not, then you check if it's greater than or equal to 100. Okay, then you get the 100th place, you get the 10th place. Okay, and you say this is equal to numdict h let's create an f string f that many 100 if t is equal to 0, it's exactly 100, then you should say numdict. It's already there. You should say numdict, and numdict is for efficiency. Numdict n equals result. Okay, and we need to return result and what else? Numdict. Okay. Otherwise, return whatever the value is equals num the tense part result and num dict 1 this and num dict. Okay, one, and then return so we have a result which is so many hundred and result 1 and num. Okay, we have handled everything. That's 100 and something. Then we have to go to 19, 20 and greater than 20. If n is greater than 20, because 19, okay, n is greater than 20. Okay, we need to find units place, tens place equals n by 10, that one, and the tens and units place is n percentage 10. Okay. Equals numdict n into 10 equals so the units place, we should have the units place like right over here. So the value is mounted and the units place is just whatever is remaining units place over here. Okay, that's the equals F result like that 25, so it'll be 25. Okay, and object n equals result and return result and numdict. Okay, where do we have this? Hundred. Is really where the problem is? While F string line 1. Ah. Like that. Okay. Let us say 5. It should be 5. 10. It's 10. 100. 100. Okay. 200 is 200. How about 342? 342. We have a problem. Key error 420. Okay. N is greater than 100, so we should have 300. Okay, 300. The 10th place. So it came to 300. So it came to 42. This should be 10. 342. Look at that. This has 42. It does not have 342. I am not unticked. That's the final result for n equals, and I should say result 342. I have 342, I have 42, and I should also have 300. I have 300? I don't have 300. Why do I not have 300? Never mind. But what if I do 300 over here? 300. Okay, I think this should suffice. So we start with a particular non-dict, like that, and that's non-dict, and for I n 100, 1 to 100 and 1, so that's 1 to 100. I and non-dict equals that, and print I, that's 5D, and result. Okay. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 21, 22, 23, 40. What's correct? 40. 40 should be F-O-R-T. Yeah. Thirty, 40. Make sure I have the spellings right. Thirteen, 14, 15, 16, 17, 18, 19, 20. Verse 20, 30, 50, F-I-F-T-Y, that's 40, 50, 60, 70, 80, 80, 90, and 100. Can I go to 200, 200, 199, okay. We have to n equals 100 and 20. Space with nothing, and I need to find the length of this. Length, and I will put the length over here, and okay. So 33544, 33544, okay. 342 contains 23 letters. 340. Let's go from 201 to 400. 342, 23 letters, okay. 115, 100 to 200, 115, 20 letters, okay. So given that, then we go from 1 to it happens to be all the way 17, 100, 100. That is not what we want. Wait. We only prepared for up to here. 1,999. Okay. So we need to sum all of this stuff. Totals. N and totals is that. Hopefully this works. I don't know. Okay, so this is problem 17 solved. So we will stop over here and we will continue next time. Okay, bye bye.